Okay, so let's think about quadratics. Y is equals to ax squared plus bx plus c. We have this nice general form. And what we're going to do for fun is we're going to play around with factoring out the a, and we're going to try to complete the square. So this is a bit harder because there's no actual numbers, but we know how to complete the square. When you feed the dog and you feed the cat and you multiply this out, the a's cancel. You can see that this is equivalent. We're going to really focus and underline the part that we're going to complete the square on. So now, for the first time ever, let's use strong brackets here. Leave a lot of room. We're really going to concentrate on completing the square here, something squared. It's going to be x plus b over 2a, because this is half of this coefficient. Your tummy's full. You're going to subtract this squared. B over 2a squared is b squared over 4a squared. And now let's feed the dog and let's feed the cat. Distribution. So we have a x plus b over 2a all squared. And when you go this times this, you have a negative answer, and you have a ab squared over 4a squared. And notice how one of these a's cancel. So when you divide the top by a, it disappears. And when you divide the bottom by a, the squares simply disappears, and you just have a there. And the plus c is over here still, so let's rewrite this as plus 4a over 4a c. This is the same thing as 1. And now you can even combine these if you really wanted to. So let's just give it a try here. So if you combine this into one term, we have minus b squared plus 4ac all over 4a. So notice how this is the completed square version, and this here is your x value, and this part here would help you with the y value. Now be careful. X is not b over 2a. X equals negative b over 2a, because we want to remember that when you have a basic parabola such as y equals x minus 2 squared, we know the parabola is shifted 2 units to the right, and it looks like this, and it cuts through 0. The vertex should be 2, 0. You can see that when this value is negative 2, it actually means 2 to the right. So when this value is b over 2a, you know that x is going to be the negative of that. So this here is the equation of the line of symmetry. And it also happens to be the x value of the coordinate of the vertex. And you don't have to memorize it, but just out of curiosity, this happens to be the y value of the vertex. We can test it out here. I'm just going to expand out this concrete example. Y equals x squared minus 4x plus 4. So you can see that a equals 1, b is equals to negative 4, and c equals 4. So just to test out the y value, which should be 0, let's substitute these a, b's, and c's in. So this happens to be negative b squared, so this is negative 4 squared, plus 4 ac, a is 1, c is 4, all over 4 times a, which is 1. So we have negative 16, and we have plus 16 that came from 4 times 4, all divided by 4. And you know that negative 16 plus 16 is 0. 0 divided by 4 is just 0. So this indeed is the correct y value of the coordinates of the vertex. Okay, so let's carry on and take this further to show that the quadratic formula is true. X equals minus b plus minus square root of b squared minus 4ac all over 2a. So the idea of solving or finding the roots or the x-intercept is all about setting y equals 0. So we're going to continue off what we did last time. And so what we're going to do here is we're going to throw this term over to the left where the 0 is. So this, we'll consider this a positive term. But when you switch it over, it becomes a negative version of that. And you have to be very careful with where your brackets are, or what's on the numerator and what's on the denominator. Do not accidentally forget the brackets. So it's minus of this whole term, and that replaced the 0, is equals to a. I'm just copying this part up here. X plus b over 2a all squared. Okay, so I don't like this negative business here, so I'm going to just distribute negative here and here. So we're going to multiply the top by -1. So what ends up happening is this negative sign disappears. We're going to switch this to a positive, and we're going to change this to a minus. So I can see that a bit more clearly. Let's divide both sides by a. So when you divide both sides by a, what ends up happening is this a disappears. However, think about it. This becomes a squared because an extra a ends up on the bottom, not the top, because we're dividing by a. So as a fair Texas judge, yeehaw, we're going to square root both sides, and we're going to get x plus b over 2a, and you have something squared, so it's going to be plus minus the square root of this entire thing on the left. So b squared minus 4ac all over 4a squared. And so let's focus on this part here. This part here happens to be plus minus the square root of the top over the square root of the bottom. So the square root of the top is going to be b squared minus 4ac, and the square root of the bottom is simply going to be 2a. But notice how x is equal to this business here. Take away b over 2a. So we're going to subtract b over 2a here is equals to x. And notice the common denominator, so we can put it all together. We're going to say that x is equals to minus b, that's this part over here, the numerator, plus minus square root b squared minus 4ac all over 2a. And there we have it. We have the quadratic formula. So for enrichment, can you prove these equations?